As a warning, picric acid is both toxic and explosive. Waste produced from this experiment will mostly be water with picric acid dissolved in it. This cannot be poured down the drain. Picric acid readily forms shock-sensitive explosive salts with many metals. Picric acid is mostly used as an explosive, but it does have some limited use in organic chemistry. Picric acid can be used to make ammonium picrate, also known as explosive D, which is an extremely useful and relatively safe high explosive. For this experiment, I used 5 grams of phenol, 10 milliliters of concentrated sulfuric acid, and 7 milliliters of concentrated nitric acid. Although I used phenol, you can also use 3.75 grams of salicylic acid or 3.2 grams of acetylsalicylic acid. 5 grams of phenol is added to a round bottom flask. To this is added 10 milliliters of concentrated sulfuric acid. The mixture is then stirred and heated at 100 degrees Celsius for 30 minutes. The reaction occurring at this point is shown on the left. At 25C, there is an equilibrium and the major product is the ortho product. However, when held at 100C, the equilibrium is broken and the major product formed is the para product. After 30 minutes, the reaction mixture is removed from the water bath. At this point, the reaction mixture should have a red color to it. With the flask cooled on an ice bath, 7 milliliters of concentrated nitric acid is added. The initial reaction is extremely exothermic and it's very important to use an ice bath. Prior to the addition, the nitric acid was cooled to about 0 degrees Celsius. Because the nitric acid was cooled down, it takes a little while for the reaction to start going. A lot of nitrogen dioxide gases will be formed, so this cannot be done inside and must be done in a fume hood or outdoors. According to a resource that I found, this is the reaction that's occurring. As said before, the first reaction was a sulfonation and left us with mostly the para product. Then, according to this source, it's nitrated on the ortho position and then it can follow 2 different pathways where both ultimately lead to the final product of picric acid. Although the reaction appears quite violent and exothermic, it is actually not complete once it dies down. If we isolated our product after this point, we'd have mostly the mono and dinitrated product and not as much picric acid. We are going to need to heat up the solution a little bit to get the third nitro group onto the ring. After the violent reaction is over, keep stirring to expel as much of the nitrogen dioxide gas as possible. The reaction mixture was transferred indoors, and at this point you can see the formation of some yellow crystals. The mixture was then heated between 95 to 100 degrees Celsius for 1.5 hours. You'll notice that gradually the orange color disappears and the solution obtains a clear red color again. After 1.5 hours, it's placed on an ice bath and cooled to about 0 degrees Celsius. Then, about 60 milliliters of ice-cold water is added. This will cause the picric acid to precipitate from the solution and a very nice yellow color will arise. Keep this stirring for several minutes. The flask is removed from the ice bath and you can see the picric acid crystals which have precipitated and settled at the bottom. The picric acid crystals were gravity filtered and washed with a copious amount of cold water. In general, with materials which are potentially explosive, it's advisable not to vacuum filter. Eventually, we're left with some damp picric acid crystals at the bottom. Using a plastic spoon, the picric acid was transferred to a beaker. Using water, the picric acid was recrystallized, filtered, and transferred to a dram vial. This is my final yield of picric acid, and I'm actually not sure how much it is. I chose not to deal with any dry and potentially explosive picric acid, so I never got a chance to weigh it. For storage, it's always important to keep it under a layer of water.